First of all, thank you everyone for coming along to my talk. My name is Matt York, so I'm a solutions engineer at JFrog. And one of the things that I'm hoping to talk about a little bit today is around kind of consistency, specifically in the security space. Just some really quick background. So hands up. First of all, how many people here are actually developers? Okay, that's good. I'm feeling a little nervous now, but that'll do. Are there any security people here? I like how you've seen how many developers there are, and you're now not sure if you're going to put your hands up. So that's fine. I understand. Cool. Okay. So just quickly, my background. I'm a confession. I am not a developer. I've actually come from an infrastructure and automation background. Spent kind of far too many years in industry, then 10 years at Red Hat roughly, and then I've come to JFrog doing all kinds of weird and wonderful things. I'm also not a security analyst, so I don't have necessarily that full background, but I'll explain to you why hopefully this talk will still be relevant. My background is predominantly around infrastructure automation and management. The reason that I kind of ended up at JFrog is because lots of the problems that we're trying to solve aren't necessarily technology specific. A lot of it is around how teams work together. And when I was working specifically in automation, the hardest part of my job was not writing Ansible, it was not writing Terraform. It's trying to get teams to allow me to enter their world and to help them automate and to get those silos working together. So hopefully this will be, hopefully that's what you're expecting, and so we'll be going through. So I guess in terms of the purpose of the talk, I've been at JFrog now for 18 months. And although it doesn't seem like a very long time, I've worked in different areas of the business, and I've been spoken to literally hundreds of customers, and there are certain themes that I see. Sometimes I have security teams coming to me saying, we want to automate our SDLC, we need to have more security, we're concerned about risk. I also get the chance to sit down and spend time with developers and listening to the challenges they have when a new security tool is imposed upon them. And actually, hey, look, we've got a job to do, right? We need to churn out code. Our management are expecting us to churn out code, and this is getting in our way. It's slowing us down. So we'll talk about some of those challenges as we go forward. I guess that the main problem is how do we help everyone to get what they need to get done together without reducing the friction as much as possible. So this is not going to be a product sell. I'm using it as context because as we go through, I'm going to be sharing experiences I've had with customers and briefly explaining what the platform does, where it plays, how it works with people is kind of key to that. From a JFrog perspective, we are working with developers in terms of helping them to understand the OSS packages that they're pulling in, so dependencies. We're helping them to build, manage, secure their code going through pipelines. We're then helping them to store that, being able to promote it, put it through release lifecycle management, going through the whole CD process, deployment into runtime, and all of those good things. It sounds really easy when you say it in 20 seconds, but that's kind of the life cycle we're looking at. We'll also, things that feed into that and the challenges we have are things like regulations. So things that security teams have to deal with. Regulation that comes in means that they have to make change. But the way in which we do that is hopefully what I'll be talking about as we go through. And also some of the new tooling that's becoming available to developers that, not necessarily JFrog specific, but tooling that will allow you to get a better developer experience. And that's a really big part of this. When we're introducing change, we need to make sure the developer experience is a good one and something that they want to engage with. Otherwise, we end up with this butting of heads and things start to escalate. So originally, this talk's been through about 10 different iterations. We decided that the sensible thing to do was to put a LinkedIn poll out a little while ago and ask, what did people want to see from this talk? Almost everyone was coming back with reducing friction between teams. So that's kind of where the focus is going to be. There will be a gratuitous amount of AI-generated frogs. It wouldn't be a talk if it didn't have AI-generated images. I'm still not bored of it. So, my next favorite thing, apart from AI-generated images, is also to massively stereotype roles. So I'm going to put you all into boxes. You can all disagree and come and hit me later on. It's fine. So for these examples, I'm picking on 3 key personas at the moment. The first one is going to be the developers, obviously the AppSec guys who have to maintain controls and governance, and then also the leadership who are there to make sure the pressure is maintained. I'm sure they have other functions as well. So we're going to talk a little bit about some of the areas of responsibility. And if we break it up into the kind of standard SDLC phases, for developers, we're going to be talking about and showing you how we can help developers with tooling to help them curate, so decide which packages to use, how do they make good decisions, how do we make those decisions early on so that we're not then having to unpick changes, like change our framework halfway through a development lifecycle or something similar. I've put DevOps in there. I put them in there briefly because I should describe what I mean by DevOps because obviously it means everything to everyone. In this situation, I am talking about the DevOps team that are managing much of the infrastructure, much of the container-based images you might be using for deployment, effectively the non-development side of the SDLC. And then we've got the AppSec teams who are obviously responsible for ensuring good decisions are being made all the way through, visibility, auditing, all the usual things. And then finally, we've got the leadership who are obviously going to be looking at how do we make sure that everyone's working together, and as an organization, we are delivering what we should be delivering. How do we make sure the applications, services that are being written are fit for production, but also are getting delivered on time? This talk won't all be slides, by the way. This is just to set the scene, really. So I told you I was going to do lots of stereotyping, and hopefully I'm not going to get lynched by all developers. I'm now folding my arms. I can feel I'm nervous already. So things that I've noticed developers have told me they want to be writing new code, right? They want to be writing new productive applications, services. If they have to, perhaps some maintenance in there. Fixing CVEs is not generally something that makes developers particularly happy. So if we can avoid that, that's something that we'd like to try and do. We know that when a new library comes out, it gives new options to developers. So being able to use that kind of new functionality is something that's quite important certainly to our customers. When security teams put barriers in the way of developers, it turns out that developers are actually really smart. And developers are really good at getting around barriers. So if it involves disconnecting a laptop from the corporate network to pull dependencies in from a coffee shop Wi-Fi, it has been known to happen. And finally, why would you employ a whole heap of smart people and then not allow them to make their own decisions? This is all about control. It's all about domain knowledge. If you have an expert in a domain, they should be making those decisions. What we want to do is to help give the right information at the right time to allow those developers to make those. Based on my poll of about 10 customers that I know are really active in this space, they told me they don't like being asked to wait. Having to wait for other teams is very frustrating. When they're writing code, they don't like having to switch to another tab. They just want to do what they need to do within the IDE of their choosing. Retesting because a new library has been imposed on them, or having to regress to a previous library version, retest everything. Even if it's automated testing, it's a frustration. Nobody comes to work to receive a long list of CVEs from the AppSec team who maybe don't understand the context of the CVEs that are being given, and you're just being told to fix them. And finally, being told to fix things that are not relevant. That's it. No one likes wasting time. So the kind of key things that, when we're introducing a new platform, the key things that developers were looking for was kind of what's in it for me. And that's like, what does it mean for my time? How is it going to help me go faster? What does it bring to my experience? Why are we doing this? And that communication of understanding why that's important. And then there were other knock-on kind of statements that came back, which is like, why do I have to change my workflow? What I've got works now. Why are we changing it? And finally, mandating. Nobody likes being told to have to do something, especially if it's not clear why you're doing that. From the AppSec team, and I know there's not many of you in the crowd, so I guess I'm playing devil's advocate here. We have, they need to be able to understand the risk. It's not so much that they want to, it's because someone's going to ask them. If something that escapes into production that shouldn't, they're the team that are going to take the hit as to why wasn't this spotted. How do we go back through the audit of everything that's been done to make sure we understand why that was a challenge? What are their confidence levels in the risk and the process that we have? And they love a dashboard. Everybody loves green lights. Oh, I like blue lights, apparently. And they effectively will, they want to see the status at any given time of what's going on. Things that they struggle with are unmanaged risk. If they don't know about it, it makes them nervous. They start asking difficult questions. We end up in a situation where there's a lack of trust. That starts to break down and that causes problems. Being ignored, this may come as a surprise. Sometimes developers won't necessarily respond in a timely manner to application security teams. Apparently that's frustrating. Surprises, yeah, nobody likes surprises. And finally, manual intervention. If it's something that we can fix in a pipeline, let's fix in a pipeline. So things that they were looking for are kind of more confidence. How do they know what's going on? They don't want to have meetings with developers any more than developers want to have meetings with them. So how do we automate some of that to reduce the risk? I'm probably painting a really horrible picture here, but hopefully we can help with some of it. And then finally, reduce reliance upon other teams. If they have the information, they don't have to go back to somebody else. Leadership, I'm sure you could all add your own little comments here. But from a leadership perspective, they care that everybody is playing nicely together. That means that products are getting shipped out the door, they're getting shipped out securely, and they're not getting, ending up on the register, which is not what anybody wants. So really quickly, and I've talked far more than I probably should have on that, but some of the key challenges are that developers don't want roadblocks, they want to write code. They want to write new code. They want to be doing the interesting reason that they went into software development in the first place. Security teams don't really want to be seen as a department of no, but they also need to be able to get their job done. So that's a challenge. And then management just want all of the things to happen really well with no stress, and everything gets delivered into production securely. So now how do we fix some of this? So some of the customers that we've been working with, the first thing is standardizing the vulnerability data. Okay, so we need to make sure there is nothing worse than when you have the development teams who are developing their code, they're testing it, it's all secure, they know. It then gets pushed into another set of tooling as it moves into production, and all of a sudden a whole new set of vulnerabilities are discovered. This means that there's suddenly a discrepancy. That's immediately going to cause someone from the application security team to start having an unwanted conversation with a developer who also doesn't want that conversation. There is and there's something that needs to be resolved there. So by standardizing the vulnerability data, whether it's CVEs, whether it's whether it's SAS testing, DAS testing, whatever it is, as long as we're all singing from the same hymn sheet, we can have a constructive conversation. I'll talk a bit about the carrot before stick approach. What we try to do is, at the very start of the process, developers are the experts in their domain. So they know what frameworks they want to use. They understand the architectures they're going to use. They know which packages they want to pull in. They know how they write their code. They know how it's structured. So what we want to do is to give developers as much information as we can at the start, advising them what the risks are of what they're doing. What we need to make sure we don't do is put roadblocks in the way to slow them down. This encourages a behavior of helping people to do the right thing, make it as easy as possible, and then gradually, as we start to move closer to production, there's more screws, more sticks, more beatings, the usual thing, as we start to move into the production space. Agreeing on common criteria sounds like a really obvious thing, but having things like bringing some of the AppSec guys into that early decision making, even just to kind of listen, to understand what it is that you're going to be testing for from a security perspective. Are we going to say critical and high vulnerabilities will be completely blocked and we can talk about the rest? Are we going to talk about coding standards? Are we going to talk about what's acceptable, what's not? By agreeing that in advance of writing a line of code, we can start to put the blocks in place to avoid conversations when the code's already been written and things have to be changed. I know that term shift left is overused, but this is very much what we're trying to do in terms of providing information, setting the ground rules early so that we don't have surprises later on. Just thinking, oh yeah, and finally, once we've agreed some of these rules, hopefully we can automate some of them into our pipelines. So again, it means less developer interaction unless something goes really wrong. The more we can automate, the better. And I'm going to be honest, this slide was mostly because I like the pictures of the frogs, but I'm gonna go anyway. The point here is that during that kind of curation stage, that creation stage where you're writing code, there is very little to no control from an application security team. There's lots of guidance we'll give you, but there's very little in the way of mandating roadblocks. As we start to move into the packaging phase, so we're talking pull requests, we're talking build processes in CI, we can start to put break glass controls in there. If something has critical issues, we probably don't even want to build it. And then gradually, as we start to move towards promotion, distribution, we can put much harder controls in there to make sure that content never makes it any further. Demo time, okay. So what we'll do is, and of course I have to re-log into everything, wonderful. Why wouldn't I? Okay. So while that's logging in, I'll show you something else. So let me show you I'm going to show you the ID. So JFrog provided a number of tools. Yeah, I'm talking about JFrog tools here, but I want you to take away the concept. This isn't just a product selling session. So the point of what we're doing here is we provide a series of plugins for the kind of common IDEs that exist. So IntelliJ, VS Code, Visual Studio, the usual suspects. Nothing for Vim yet, which makes me very sad as an old infrastructure guy, but I think it's probably just me left that's doing that. What we have on the right-hand side here is a list of vulnerabilities. So it's just an Express.js application, and what's happening is the code that's locally on my system, so it's not checked out of, it's not in any version control at the moment. I'm actually pulling the vulnerability data over from my JFrog platform. What it's doing, it's building a dependency graph of my code. There's two things that happen here. The first one is we're identifying CVEs and the dependencies that exist. To feed into how we might help the developers here rather than get in their way, it's all about providing relevant information at this point. So obviously we show them where the vulnerability is. And the first question that any developer wants to know is, what do I do about it? Do I need to do anything about it? So as you'll be aware, so JFrog have a security research team behind the scenes. They don't write the application. They're just doing security research. They're what they call a CNA, so they're a CVE numbering authority, so they're actually doing discovery. They're actually finding vulnerabilities. And I've got a little story about this later on if we have time. But what they're doing is they take all of the available information and they provide that to developers in the IDE. So the first option, which is what you'll see on any CVE, is go and update the package version. Now, we know in the real world that's not always possible. There are a number of reasons why you may not be able to update dependencies at that particular point in time. So we also try to provide mitigation information. And so here you can see that there is, okay, really you should be updating the package. However, you can mitigate the risk by carrying out X, Y, and Z, and that's listed here. We also provide the CV information, so without leaving the browser, without leaving the IDE, all the information on the vulnerability is here, and as well as all the public sources you'd expect. We provide an impact graph, so it shows you where the vulnerability exists. And probably the most interesting part from a developer perspective is something called contextual analysis. So what this is doing is it has one dependency graph that says everything's being imported. Then we're also looking at the code that you've written and understand how that's interacting with those dependencies. So if those dependencies aren't calling the method that's affected by this vulnerability, we can actually grey them out. And what this does from a developer perspective is it helps you to focus on what's actually going to cause you problems later on down the line. So this means, in this particular case, there's 4 vulnerabilities that we should be addressing, and these 3, we should be aware of them, but at the moment you're not being impacted by them. Now, it's not just a case of JFrog. JFrog said it's okay, so trust me, bro. Unfortunately, that doesn't stop the register from printing things. So what we do is we actually provide information as to what we looked for, why we think it doesn't apply to your code, and we give some reasoning here. And we also provide an entire research page. So this isn't written by AI. This is generated by hand by our research team, because the consequences of getting this wrong or some kind of hallucination would be, it would probably end JFrog pretty quickly if we told people things were okay. And we explain here about the exact state of the issue. We describe the details. We describe what increases the risk of this vulnerability, what could decrease it. All the information you need, although you might not need it all immediately, if someone in AppSec perhaps disagrees with you and they come back to you 2 weeks later, you can open your IDE, you can look at this, and you have all the information you need to have that constructive conversation. You don't have to suddenly go and do a whole heap of research 20 minutes before a call. So this is really something that's quite powerful. There's also, within the IDE itself, we also support things like SAST, so there's best practice for a lot of the kind of code quality side of things, as well as things like secrets detection. And there's also some infrastructure as code scanning as well for things like Terraform. So this is still at the very beginning stages of the process, but you can see there's no blocks. There's nothing in here that's going to stop you from committing this code, creating a PR, and submitting it. So the next phase of this, in fact, I'm going to go back a step quickly. Before we've even written a line of code, we've talked about developers making good decisions about frameworks they might use. And maybe it's an architectural board and it's not the developers. There's something called curation, which is part of the JFrog platform. And what they're doing is we're actually scanning most of the open source repos for a number of different languages. So what we are able to do at this point is to provide almost real-time information of the state of a package that's upstream. So for example, I'm definitely going to get lynched now, so I'm a Python developer rather than anything else. I realize I'm in a room full of Java developers, so I might regret this. But if I pick a package for Django, give you an example of how this could help me make a good decision. I can click on the package, and I can go through every version of that open source package, and I can understand when it was published, what the license is, how well maintained it is, what vulnerabilities are in there, what's the transitive vulnerabilities. This gives me the historical information to allow me to make good decisions for the future. So it's not going to be perfect, but it's going to give you at least a basis to help make those decisions before you even write a line of code. The second part of this is something called curation, which is like a policy engine. So you can use this information, and you can use this to create a rule set. So you might, for example, I was working with a gaming company, and they told me they could not use a GPL v3 license. I don't know why, but in their organization that was not acceptable. Curation will act as a package firewall. So it means that the developers can never actually pull that package in. Now, as developers, you're probably thinking that's quite frustrating, like, that I don't want to block me. To make this a bit less painful for the developers when you can't pull it in, this is connected with things like GitHub Copilot. So as a developer, I'm trying to install my package, and it says, oh, you can't pull it in. I can ask GitHub Copilot and say, why can I not install this package? It will query curation and say, your organization has blocked GPL v3 licenses. Your next question is, well, what would you suggest I use instead? And it can then give you a recommended list of options. So the developer experience, so the worst case is we've stopped you from doing something as a developer for a reason. But we make sure that you have the integration with things like GitHub Copilot to be able to ask, why is that the case? What would you suggest I do? So yeah, again, this isn't a product sell, but it's to give you an idea of how we can make, whether it's our tool or somebody else's, give you an idea of how you can make this process a little bit easier going forward. The next step are things like, so we start moving to the next stage. Okay, we've written our code, we've created a pull request. If we have a look, now as a developer, if I've just ignored all the warnings and went, I'm going for it, I'm sure that would never happen to this audience, but you know, things happen. One of the things that can happen is you raise the pull request, and there's a bot that will create, you can configure this, and it will actually create a comment on the PR that says, someone submitted some code, and we did a quick check on it, and you should be aware there are some issues, or maybe there's not some issues. You can create policies to define exactly what's being shown here, but these are examples of how they're starting to build up an audit trail. So if, as you as a developer, this can actually protect you. The reason being, you write some code, a vulnerability is discovered after you've built your artifact later on. Your AppSec team come back to you and go, why did this escape? You've got something to show them. Well, it was a 0 day. It didn't exist when I had committed this. So again, we're reducing friction. In a perfect world, the AppSec team will check this themselves. Saves you a phone call. Yeah, so, and if something does appear later on and you need to remediate it, you open your IDE. The vulnerability is now visible, so you can then start to remediate that. It can also be run on a regular basis as well. So over time, vulnerabilities get discovered. It can also create things like pull requests for updating requirements and such as well. From a pipeline perspective, so we actually have a command line tool that will allow you to do some of this scanning. This is a little bit more powerful. So this is the command line here. And all I'm saying is I want you to scan the source code that's in this directory, and I only want you to show me the high or critical vulnerabilities. This is really useful from an actual build perspective when we're starting to go through that. What this now gives me is a tabular format that I can then feed off to my logs, however I want to do it, of what the state is. Now, an extra control we're adding in at this stage is we can create a policy within the platform that says, if I run this and I find a critical vulnerability, I want you to force this command to exit with a non-zero status code. And that way it will break the build. So if you need to, you can start to implement those kind of break glass controls at this point. And this is obviously looking for secrets and a number of other things as well. And then finally, let me find, hopefully we're logged in. So this is probably more from the application security team. So this is maybe the view visibility they will get. And this talk is all about consistency, and hopefully you'll see why I called it that at the start. So what we've done is, this is an example of the code that you had written, or the code that's been written. All of the dependencies that were required to build this, they were all put inside a container image, and then they have now been stored in the Artifactory platform. So as you can see, to an application security person, this is going to light up like a Christmas tree. They're going to come in here and go, right, we've got 21 criticals, we've got 130 highs. We probably don't want this going into production at this point. So we can drill down into this container image. And then we can see, okay, so there's a vulnerability here in Express.js. There's a vulnerability here, Express.js. There's a node issue here. But most of these issues are actually being brought in through the through the container image itself. Without this context, there will be a whole list of CVEs. I guarantee you there will be a whole list of CVEs exported and sent to some poor developer to go, can you explain to me why we've got these issues? And obviously you'll go through it and go, look, this is an issue with Debian, but it's not, it still stops the developer from writing new code. So it's again another friction point. Here, it's pretty obvious that if we can update the base image we're using to build our application on top of, we're going to mitigate a lot of these. There's potentially 3 issues that need to go back to a developer to be looked at. And the information that's here is consistent with what you see in the IDE. So if something's broken, there's no need for an email, a copy or paste. You can just open this version of the code, and you will see exactly the same issues there that need to be resolved. So that consistency is reducing the need for all those conversations. Again, for the security teams here, we give them the same information. We say whether it's applicable. We explain why we think it's applicable. So they don't need to come and have the conversation with you. They don't need to understand what the dependency is. We can give them enough information to hopefully let them understand whether it really is applicable or not. Or well, this application is running behind 3 firewalls in the back of a basement somewhere. And this extends to beyond just this side of the platform. It can actually extend into runtime as well. So vulnerabilities get discovered all kinds of times. Sometimes they'll get discovered once they're actually in production. At this point, the security teams can see the containers running in a particular Kubernetes cluster, and they can actually identify the vulnerabilities. And when if you go back, open your code in the IDE, you will see the same vulnerabilities there. So that consistency is, again, preventing those difficult conversations between teams. So I'm actually way ahead of time, but I'm not going to talk to you for longer than I have to. So I don't want to put you through that. What I'm going to do is, have I got another? Yeah, so I'm just going to go back through to summarize some of the points that I've kind of called out. So the first thing is standardizing that vulnerability data is the most important thing. I know every team has their own set of tools, and I'm not saying they shouldn't, but when you are going through a process of telling a developer that what they've written is insecure, you need to make sure they're looking at the same data. Otherwise, you're going to end up in these endless conversations that never end. It's going to break down trust. You're going to really struggle to get those teams to work together well. Carrot before stick approach is you've got really smart developers. Give them the information to make their own decisions. If they disagree with what JFrog are suggesting, that's fine. Later on, when you come back and ask them, they'll know. They've got the same information. Again, agreeing common criteria. No surprises. Working groups. Talk to each other. But do it early. Do it before you start writing code. And then finally, again, a lot of the rules, things we've talked about, use the tools, whether they're JFrog tools, whatever they happen to be, use those tools to build it into your pipeline. Automate it as much as possible to avoid any surprises. And I said I'd drop in a story, so I'll be really quick with this one, but we had I told you a minute ago about JFrog have this security team, and they do work quite independently from like the application teams as such that we have. One of the things that's important to their role is they are constantly looking for vulnerabilities out there in the wild. Right? And that means scanning things like Docker Hub. It means looking at these open source repositories to identify potential issues. I'd been in JFrog for maybe a month, and I had a kind of call from one of the lead security guys who said, we need to talk to one of your customers. And the customer will remain nameless for obvious reasons in a minute. They said, can you get me a call? We need to speak to their application security team. We think we found something of interest. So myself and the sales guy that we work with joined the call. And there were 3 of this customer's application security teams asking what's happening. The our team would not tell me anything in advance. For security reasons, they don't want me knowing about a vulnerability in a... So I'm as surprised as they are. They said, OK, we found one of your containers on Docker Hub, and there's an access key. Well, there's 2 access keys in there that have been left in the container. One of them is for your GitLab public instance that has access to 1,800 repositories. 900 of those repositories are applications that handle publicly identifiable, personally identifiable information, and those keys have been there for 6 months. The second one is it had your Slack admin access token in it as well. So yeah, it was, and I watched 3 people literally turn grey on a call in front of me. It was probably the worst phone call I've ever been on. But it was, and I dread to think how the developer who left them there felt at the end. But something I hadn't really thought about that much was secrets being left in containers. And I mean, that was, I cannot imagine how much effort it took to revoke those keys on all of those repositories, go through every single one of those repositories to make sure, have there been any inadvertent pushes to it? What's the code? What's changed? Someone's going to have to review all of that before those applications were allowed to be kind of put back into. So anyway, I thought I'd share it for you. I still have nightmares about it, but that was it. So I've come in far too early, probably because I talked too fast. So any questions? Does that make sense? Was it helpful? If it wasn't, that's fine. Go for it, yeah. Mm-hmm. So you mean with, will we integrate? So we'll only do this, so within the JFrog platform, there is the repository exists there. So whatever container you're scanning would need to be pulled into that repository. It only scans in the JFrog platform. But whichever tool you use, the main concept is just to make sure that, yeah, you're kind of scanning that. So, any other questions? Quite a really easy audience on me. I was expecting more abuse. This is good. So if you do have any more questions, we're down on the stand. I'm sure I have many more war stories. Happy to share, talk through any of the components. And I'm giving you 12 minutes back, which hope you can get to lunch a bit early, maybe. So, all right. Thanks very much.